We'll start in 1 minute. In a few minutes, we'll be in section 9.3. That's the section on the quadratic formula. But first, we'll do one more problem from section 9.2. So we're solving this quadratic equation by completing the square. So one thing you should know, perhaps you've already noticed, that every quadratic equation can be solved by the completing the square method. Okay, to solve this one by completing the square, first add 8 to both sides, and we get 2y to the second minus 14y equals 8. Then observe or note that the coefficient of y squared is 2. We want the coefficient of y squared to be 1, so we're going to divide every term on both sides of the equation by 2, and we'll get y to the second minus 7y equals 4. The next step is the completing the square step, or you could think of it as the creating a perfect square trinomial on the hand side of the equation step. So what we do, now that the coefficient of y squared is 1, we take 1/2 of -7. So 1/2 times -7 is -7/2. Then we square that number. The number -7/2 squared is 49/4. And this number 49/4 will be added to both sides of the equation. In so doing, the left-hand side will be a perfect square trinomial. So y squared minus 7y plus 49/4, and 4 plus 49/4 on the right-hand side. On the right-hand side, we need to add 4 to 49/4, so the least common denominator is 4. So this will be 16/4 plus 49/4. The next step, now that we have a perfect square trinomial on the left-hand side, we're going to write it as a binomial squared. To factor y squared minus 7y plus 49/4. We know that it's a perfect square trinomial, so we need a binomial squared. The right-hand side becomes 65/4. So how do we know what binomial we need to square in order to get the perfect square trinomial? Well, in the perfect square trinomial, the first term is y to the second. So the binomial has to have y. And then how do we know what follows y inside the parentheses? It's the same number that we got when we took 1/2 of -7. So minus 7/2. And so we have the binomial y minus 7/2 squared equals 65/4. And now we can apply the square root property, and we'll get y minus 7/2 equals positive and negative square root of 65/4. In the next step, we'll do a couple of things. We'll add 7/2 to both sides, and we'll also simplify the square root of 65/4. So we'll get y equals positive 7/2 plus and minus the square root of 65 divided by 2, because the square root of 4 in the denominator is just 2. Okay, so those are the two solutions. If you want to write them separately, you can. In Newton, you do have to enter the solution separately. So I'll write them separately. One is y equals 7/2 minus the square root of 65/2. The other solution is y equals 7/2 plus the square root of 65/2. All right, now we'll move on to section 9.3. Section 9.3 is about the quadratic formula. So as I mentioned, any quadratic equation can be solved by completing the square. So consequently, a formula can be derived by completing the square that can be used to solve any quadratic equation. That formula is called the quadratic formula. And we will derive the quadratic formula in the space below. So we just proceed like we did in the examples from section 9.2. Ax squared plus bx plus c equals 0. So step 1, we subtract c from both sides. We get ax squared plus bx equals negative c. The coefficient of x squared is a, so in the next step, we're going to divide every term on both sides by a. And when we divide every term on both sides by a, we get x squared plus b over a times x, and on the right-hand side, minus c over a. The next step is the completing the square step. which means that we're going to create a perfect square trinomial on the left-hand side of the equation. So we have to add something to both sides that will make the left-hand side a perfect square trinomial. And what we do here is the same thing that we did when we solved equations by completing the square in section 9.2. We're going to take 1/2 of the coefficient of x. The coefficient of x is b over a, so 1/2 times b over a, we can write that as b over 2a. The next thing we do is square b over 2a. So b over 2a squared is b to the second, and then the denominator, when we square 2a, that means 2a times 2a, we get 4a to the second. Okay, so b to the second over 4a to the second, b to the second over 4a to the second is what we're going to add to both sides of this equation. All right, so we'll get x squared plus b over a x plus b squared over 4a to the second. And on the right-hand side, well, I could write negative c over a plus b squared over 4a squared, but I'm going to put the b squared over 4a squared first, and then write minus c over a. The left-hand side is now a perfect square trinomial, and the right-hand side, we're going to find a common denominator and write b squared over 4a squared minus c over a as a single rational expression with a common denominator. Okay, the left-hand side is a perfect square trinomial. So when we factor it, we get a binomial squared. On the right-hand side, the least common denominator is 4a to the second. So we'll get started on that. We have b squared over 4a to the second minus c over a. And we multiply c over a by 1 in the form 4a over 4a. Because in the denominator, 4a times a is 4a to the second. Okay, so what binomial are we going to raise to the second power? This binomial, whatever it is, squared is equal to the perfect square trinomial. So we know the binomial has to have an x because the perfect square trinomial, the first term in the first perfect square trinomial is x squared. So the binomial has to have x. And then how do we know what follows x inside the parentheses?
Earlier when we times the coefficient of x by half.
Yeah, so what goes inside?
B over 2a.
Huh?
B over 2a.
Yeah, plus b over 2a. Yep. Yeah, this is positive. Earlier when we took 1/2 of BA, we got b over 2a. It's not negative, so that means we're going to put plus b over 2a inside the parentheses. And then the right-hand side, we can now that we have a common denominator, we can write it as b squared minus 4ac in the numerator divided by 4a to the second in the denominator. And now we apply the square root property. When we apply the square root property, we'll get x plus b over 2a equals positive and negative square root of b squared minus 4ac all divided by 4a to the second. Notice inside the square root, the denominator is a perfect square, so we'll simplify that. And we'll also subtract b over 2a from both sides. So we get x equals negative b over 2a plus and minus the square root of b to the second minus 4ac and then we have the square root of 4a to the second in the denominator. And the square root of 4a to the second simplifies to 2a. So in the next step, we'll write x equals negative b plus and minus the square root of b to the second minus 4ac all divided by 2a. Hey, this is known as the quadratic formula. And for any quadratic equation, we can solve it by using the quadratic formula. So if you plan on using the quadratic formula, make sure that you memorize it exactly the way it is. If you misremember one little detail, then that throws off everything. So work on memorizing the quadratic formula, or if you don't remember what it is, you can always derive it like what we did. Or the other alternative, you can solve any quadratic equation by completing the square method. So whichever of those you choose, make sure that you know exactly the process. Okay, next we'll talk about this number that's inside the square root, the b to the second minus 4ac. The number b to the second minus 4ac that's inside the square root is called the discriminant. Hey, the discriminant indicates how to classify the solutions to the quadratic equation ax squared plus bx plus c equals 0. Okay, so there are three possibilities for solutions to a quadratic equation. If the discriminant is positive, that is, if b to the second minus 4ac is greater than 0, we know that the square root of a positive number is a real number. So that means that the quadratic equation has two different or two distinct real solutions. The formula itself indicates that that's the case. If b to the second minus 4ac is positive, the square root of a positive number is a real number. It's a non-zero real number. And so the plus and minus indicates that we have two different real solutions. So just analyzing the quadratic formula reveals what is stated in number 1. Okay, the second possibility is that the discriminant is negative. In other words, if b to the second minus 4ac is less than 0, what do we know about the square root of a negative number? We know that the square root of a negative number is non-real. It's a number, it's just not a real number. And we learned a day or two ago that the square root of a negative is a non-real complex number. So if the discriminant is negative, then the two solutions to the quadratic equation are two different non-real solutions because of the square root of the negative. And then the third possibility, if the discriminant is 0, well, if you analyze the formula, it reveals what to expect. If the discriminant is 0, the square root of 0 is 0. And note that negative b plus 0 is the same number as negative b minus 0. So that indicates that when the discriminant is 0, the quadratic equation has one real solution, but we refer to it as a repeated solution. But there's only one solution. So what is going on when there's just one repeated solution? Well, if there is one repeated solution, it means one of two things. Either the trinomial is a perfect square trinomial, or it is a constant multiple of a perfect square trinomial. So whenever the discriminant is 0, there is a perfect square trinomial in there somewhere. Okay, we'll do a number of examples where we apply the square root, right, where we apply the quadratic formula. When applying the quadratic formula, you have to make sure that you identify the numbers that you need accurately. So in order to apply the quadratic formula, we want the quadratic equation to be in standard form. So the standard form is ax squared plus bx plus c equals 0. Okay, so for this one, x squared minus 7x minus 2, the value of a is 1. That's the coefficient of x squared. B is negative 7. That's the coefficient of x. C is negative 2. That's the constant, the minus 2. Okay, and here's the quadratic formula up here. So we write x equals the negative of negative 7. This is the negative b part. So it's the negative of negative 7 plus and minus the square root of b squared minus 4ac. So inside the square root, we're going to square the number -7, the number -7 squared, minus 4 times 1 times -2. And then we divide it all by 2 times a, in this case, 2 times 1. Okay, if you want to be mathematically correct or arithmetically correct, when the number b is negative, you have to make sure that you square the negative. When you square a negative, you get a positive. In this case, when c is -2, notice that we're subtracting 4 times 1 times -2. So we are subtracting -8, which is equivalent to adding 8. Okay, there are plenty of opportunities to make little mistakes that throw off the answer, throw off the solutions. In the next step, we'll do the arithmetic. The negative of -7 is +7, then plus and minus the square root of a number. So the number -7 squared is +49. And we're subtracting -8. And then we're dividing by 2, since 2 times 1 is 2. And the only thing left to do is simplify what's inside the parentheses, or inside the square root. Square root of 49 minus -8 is the square root of 57, all divided by 2. The square root of 57 cannot be simplified any further. So in this case, we have the 2 solutions. All right, the next example, 3x squared minus 5x plus 1 equals 0. When using the quadratic formula, we just use the quadratic equation in standard form the way it's written. So in this case, a is 3, b is -5, and c is +1. Then we apply the quadratic formula. So x equals -b. So b is -5, so this is the negative of -5. And then plus and minus the square root. Inside the square root, we're going to square b. So put -5 in parentheses squared, and then minus 4 times a times c. So in this case, minus 4 times 3 times 1. And then we divide it by 2 times a, in this case, 2 times 3. So pay attention to detail, make sure that you get all of the correct things written. Okay, now we do the arithmetic. The negative of -5 is 5, and then plus and minus the square root of a number inside the square root. The number -5 squared is 25. And then we're subtracting 4 times 3 times 1, we're subtracting 12. And in the denominator, 2 times 3 is 6. And we just have one step left. The two solutions are 5 plus and minus the square root of 13, all divided by 6. The square root of 13 cannot be simplified any further. And then another detail to watch out for, you have to put the division bar so that all of 5 plus and minus the square root of 13 is above the division bar. If you're not careful when you're writing this and only put the division bar under one of the numbers instead of both, then you've written something that's not correct. So pay close attention to the details. All right, the next example. Negative 2x squared plus x plus 4 equals 0. So if we use the quadratic formula, so note that it's in standard form. So the number a is negative 2. A is the coefficient of x squared. What is b in this case?
1.
Yeah, b is 1. Plus x is the same as plus 1x. So b is 1. And the constant c is 4. Okay, so x equals negative b. B is 1, so negative 1 plus and minus the square root of 1 squared minus 4 times a times c. So minus 4 times negative 2 times 4. All divided by 2 times negative 2. That's the 2a in the denominator. Okay, so now we do the arithmetic. In the numerator, we have negative 1 plus and minus the square root of a number. So inside the square root, we have 1 squared, which is 1. And we're subtracting 4 times negative 2 times 4. So we're subtracting negative 32. So 1 minus negative 32 inside the square root. And in the denominator, 2 times negative 2 is negative 4. Well, we have a couple of things left to do. X equals negative 1 plus and minus the square root of 1 minus negative 32 is the same as 1 plus 32, which is 33, square root of 33, divided by negative 4. I believe in Newton, in the Newton problems, if you have a negative in the denominator, it won't accept that. So we need to find two solutions that are the same as these, but with a positive in the denominator. So I'll write each of those two solutions separately, because you have to enter them separately in Newton anyway. So x equals negative 1 minus the square root of 33 over negative 4. And the other one, x equals -1 plus the square root of 33 over -4. So we want numbers that are the same as those in value, but with a positive number in the denominator instead of a negative number. So how do we do that?
Times everything by -1.
Well, we have to multiply by a number that's equivalent to +1.
So 4 over 4. 4 over 4 or -4 over 4.
Well, you're on the right track in the first answer. The form that one takes is -1 over -1. So we're going to multiply by 1 in the form -1 over -1. You see what I mean? So when we multiply the numerator, -1 minus the square root of 33 by -1, and multiply the denominator -4 by -1, we're just multiplying by +1 because -1 divided by -1 is +1. And we get 1 plus the square root of 33 over +4. Now we have a denominator that's positive. And then we do the same thing with the other one. Multiply -1 plus the square root of 33 over -4. Multiply that by 1 in the form -1 over -1. So this time we get -1 times -1 is 1, and then minus the square root of 33. And in the denominator, -4 times -1 is +4. We could have avoided this maneuver altogether if we had done something from the start. And I did mention this in a previous class. We started out with -2x squared plus x plus 4 equals 0. In general, when the coefficient of x squared is negative, the arithmetic is a little more complicated. But you can avoid it if from the start you multiply both sides of this equation by -1. That's legal. Whenever you have an equation, you are permitted to multiply both sides of the equation by the same non-zero number. What you are not permitted to do is multiply both sides of an equation by 0. But if it's a non-zero number, you can multiply both sides of the equation by that non-zero number. So when we multiply the left-hand side by -1, we get 2x squared minus x minus 4. Multiply the right-hand side by -1. 0 times -1 is still 0. And then solving this equation has exactly the same solutions as the original equation, but the arithmetic will be less complicated because we won't have a negative number in the denominator if we solve 2x squared minus x minus 4 equals 0. All right, let's do more practice on the next page. Okay, well, take a couple of minutes, solve this equation by using the quadratic formula, and then we can compare notes in a couple of minutes. Okay, it's been almost 2 minutes. Note this is in standard form, 4x squared minus 3x plus 2 equals 0. A is the coefficient of x squared, which is 4. B is the coefficient of x, which is negative 3. And C is the constant, which is positive 2. Okay, so x equals the negative of negative 3. This is our negative b part, plus and minus the square root of the number negative 3 squared minus 4 times 4 times 2. And this is all divided by 2 times 4. Then the arithmetic, the negative of negative 3 is positive 3, plus and minus the square root of the number negative 3 squared is positive 9, and we're subtracting 32. 4 times 4 times 2 is 32. And then divide by 8. Okay, in the next step, x equals 3 plus and minus the square root of a negative number, all divided by 8. 9 minus 32 is negative 23. We know how to evaluate the square root of a negative. So the two solutions are x equals 3 plus and minus the square root of 23 times I, all divided by 8. Okay, so the two solutions are non-real. All right, the next one, solve this one. Negative 6x squared plus 5x plus 3 equals 0. So what are you going to do? How are you going to start on this one?
Multiply the -1.
That's what I would do. I would multiply both sides by -1 just to make the arithmetic a little bit easier. So if we multiply both sides by -1, we get positive 6x squared minus 5x minus 3. 0 times -1 is 0. And then use the quadratic formula on this equation. So for this one, A is 6, B is -5, and C is -3. So take 30 seconds or so and find the solutions. Okay, let's get started on this one. Notice that I always write x equals when writing the solutions to the quadratic equation. So if all you do is write down the right-hand side of the quadratic formula without the variable equals, then it's incomplete. So make sure you always write x equals and then put in the numbers in the quadratic formula. Okay, so x equals the negative of -5. This is our negative b. And plus and minus the square root of the number -5 squared minus 4 times 6 times -3. And all divided by 2 times 6. Okay, the negative of -5 is 5, plus and minus the square root of a number. Inside the square root, the number -5 squared is 25. And we're subtracting 4 times 6 times -3. So we're subtracting -72. So inside the square root, 25 minus -72. And in the denominator, 2 times 6 is 12. Then x equals 5 plus and minus the square root of 25 minus -72. That's the same as 25 plus 72, which is 97. The square root of 97 cannot be simplified any further, so those are the two solutions. Okay, there's a little over 2 minutes left. That's probably enough time to solve this equation. So take a few seconds, see if you can beat the clock. Okay, there are 30 seconds left in class. A is 5, B is -5, C is -4. So x equals the negative of -5 plus and minus the square root of the number -5 squared minus 4 times 5 times -4, all divided by 2 times 5. And we're out of time. So we'll do more of these problems tomorrow from section 9.3. So go ahead and sign in for attendance.
Have a good day.